One of the biggest challenges that we face when teaching both technical material and mathematics to students is providing examples. It's often tempting when we're going through examples to prepare PowerPoint slides or LaTeX slides and making them very beautiful and having all of the workings set out in the slides, and then just record a voiceover going through the solutions on either the PowerPoint or the PDF that we've prepared. Now, students tell us that they don't particularly like that form of solution. They prefer to see the solutions emerging, and in particular they prefer to see the solutions emerging handwritten by the lecturer. Now, one reason for this is that it ensures that you don't move too quickly, and it means that the students are able to move at your pace. Another reason is that it enables the students to think about engaging with the material actively themselves. Because you're writing it down by hand, the students also start to write down the material by hand. They start to think about the material and actively engage with the learning. Now, in an online environment, it's quite difficult to have this kind of handwritten solution. But there are a number of solutions. In this video, I'm going to walk through a solution using an iPad, an Apple Pencil, and we can apply this solution to both live sessions and to asynchronous sessions. In live sessions, I tend to use Zoom simply because Zoom allows me to both share the screen of my iPad and also to have a camera on me from my webcam, and also to have inputs from the PC. Now, there's no reason why you shouldn't just use an iPad as the input and use a different software system. The only reason I use Zoom is that it allows me to keep that connection with students. They can still see me, they can still see the material that goes onto the iPad. Now, let's have an example of how we might interact with students through Zoom. So I've got an example that I might want to work through, which is a problem that I've set to students in the past, where we've run a regression of y against x, and we've estimated that beta 1 hat is equal to 0, and we're asking to prove that in those circumstances the r squared is going to be equal to 0. Now, I'm not going to work through the whole thing because this isn't an econometrics tutorial. You already probably know this answer, but just to illustrate what the student would see, so it might be that we start off by writing down that the r squared is equal to the explained sum of squares over the total sum of squares, which is equal to the sum of the yi hat minus y bar squared over the sum of the y minus y bar squared. You might then go on and say, well, we know that each observation of yi hat is equal to y bar minus beta 1 hat x bar. So if beta 1 hat is equal to 0, then each observation of yi hat is equal to y bar minus 0 times by x bar, which is just equal to y bar. And then you can show to the students that the explained sum of squares is going to be equal to 0. Now, there are some disadvantages of using this format in that whilst you're writing, it's very easy for you to be looking down at your iPad, and for all the students can see is the top of your head. Now, I find it's very useful to have more than one person in a session. So in live sessions where I've got a large number of students, I tend to have myself and another academic within the room, and then I can be writing on the iPad and the other academic can be speaking directly to the students, or vice versa. Now, you can use exactly the same methods in order to produce asynchronous sessions. Now, in the example that follows, I've combined three sources. The first source that I produced is me working through the maths, but without any narration. The second source is a slide taken from PowerPoint, just reminding students what the question was. And the third source is a video of me narrating through the solution. Now, it is important when you're doing this to make sure that you are narrating at the same speed as the as the maths is going through, simply so that you're able to reinforce the material that's there. The advantage of students being able to see you is that they're able to pick up on your non-verbal communication, and there is some evidence that that aids recall for students and also lowers cognitive load for them. So let's have a look at an example. So we can represent the outcome where x is equal to 1 in our blue circle. We can represent the outcome where y is equal to 1 in our red circle. And then we've got an intersection between the two where both x is equal to 1 and y is equal to 1. Now, if we wanted to find the probability of x being equal to 1 or y being equal to 1, we're going to add together those two probabilities, but we'll end up counting that intersection twice, because the intersection appears in both the area where x is equal to 1 and the area where y is equal to 1. So in order to find the probability that x is equal to 1 or y is equal to 1, we add up the probability that x is equal to 1 plus the probability that y is equal to 1, and then subtract the probability that both x is equal to 1 and y is equal to 1 to take account of the fact that it's being counted twice when we're looking at the two individual outcomes.